Hello, my name is Swapnil Patil, and in this video, I will be discussing about a project which I have completed as a part of internship program with the Sparks Foundation. Let's see about the project. The task of the project is the prediction using decision tree algorithm. In this project, uh, I have created a decision tree classifier and visualize it graphically. The purpose of this project is if we feed any new data to this classifier, it would be able to predict the right class accordingly. The dataset uh, used to build this decision tree algorithm is a very famous iris dataset. This is the link of the dataset. In this dataset, the three types of iris flowers are classified on the basis of the attributes. The attributes are petal and sepal, as the width and length of this petal and sepal uh, categorize these types of iris flowers. Uh, Starting with the including the libraries and data in this project. First, we have first I have imported the required libraries, which is pandas library, which is used to manipulate the dataset, and the other two libraries are matplotlib and seaborn, which are used for the visualization. Then in this step, I have imported the dataset from the drive. Next step is of exploring the dataset. Uh, First, I have explored the top and bottom of 5 rows with the help of a head and tail function. You can see there are 6 columns. The first column is of ID, and the last column is a species, which is our target variable, and the remaining 4 columns are the attributes of the flowers. Iris flower, which is sepal length, sepal width, petal length, and petal width. Next, checking the shape of the dataset. As we have seen, there are 6 columns in the dataset and 150 rows. Next, basic information of the dataset. This 6 columns and the data types. The target variable is of object type. Next, looking at the statistical description of the variables of the dataset. The count, we have seen there are 150 rows. The mean, standard deviation, mean and max. The max length of a sepal is 7.9 centimeter. Similarly, the max sepal width is 4.4, and similarly it is other values. Next step is checking the null values. We can see there are no missing values in the dataset. The next step is exploratory data analysis. As we have seen, the target variable is species, the types of iris flower. There are 3 types of species are there in the dataset: the iris setosa, iris versicolor, and Virginia. We have seen the image of these 3 types. You can see every species has 50 data points in the dataset. So our dataset is a balanced dataset. Next, we can see the value count in a bar chart. Next, visualizing the independent variables, comparing the sepal length and sepal width of the 3 species. You can see here the blue color, which is of Setosa species. The sepal length is less as compared to the other two species, and sepal width is more as compared to the other species. Then the sepal length of the green Virginia is more as compared to the other two species. Similarly, we can also compare the petal length and petal width of these three species. Here also we can see the petal length and petal width of the Setosa species is very less as compared to the other two, and the petal length and petal width of the Virginia is more as compared to the other. The next step is data pre-processing. The first column of ID was no use for analysis, so we have dropped the column in this project. In this step, uh, seeing the data, checking the unique values in a target variable. We have seen above that there are the three species type. So and they are of string type. So in this next step, we have used label encoder to map this species value as numeric, which can help build our model efficiently. After applying the label encoder, we can see the values become 0, 1 and 2, which are mapped as 0 as Setosa, 1 as versicolor and 2 as Virginia. In this next step, we have split the target variable uh, species as y and the x contains the independent variables. Now our data is ready to train. We are using a decision tree classifier to train our model. A decision tree is a type of tree structural algorithm. It is a supervised learning algorithm which can be used for both classification and regression problem. Our problem state our problem is a classification problem, so we will be using the classifier. The decision tree works on a if-then statement. It breaks down the dataset into smaller and smaller subset based on the criteria, which can be linear index or information gain. So, and it develops a decision tree which contains decision nodes and leaf nodes, which we will see in the visualization. So first, here we have imported the model from sklearn library. It is a decision tree classifier. In this next step, we have fitted the model and our model and trained the model on the dataset. Next, we will see the visualization of the decision tree, which we have trained with the help of graphics library. So we can see here the first. This is the root node. The first the decision tree have subsetted the data on petal width. It is the criteria here is the petal width, which is less than or equal to 0.8. If it's true, then it have splitted the data into two, and the Setosa class, which has the petal width less than 0.8, got here, and the criteria used here is the Gini index, and same at the every step it has been subsetting the data and splitting the nodes and forming a tree. We can see how the tree is formed here. Next, we can also the next in here we have tried a different version of visualizing the decision tree with the help of D-Treeviz library. First of all, we had to install the D-Treeviz library with the help of this command pip install D-Treeviz. Then it is this tree is looking good as compared to the previous. It gives the representation and explanation very good. So here we can see the first, it is a root node. Here we can see the yellow color is of Setosa, and as we have seen before, the criteria was 0.8 of petal width. So the Setosa petal width are less than 0.8. So it have splitted here. This is a first leaf node. After that, there is no split, so it is called as leaf node. Then here the second split, it is a second node which is splitted again into this is node 3, which is again splitted in 2 like this. Here it has splitted the versicolor, and 47 data points are provided here of versicolor, and one data point of Virginia is provided on the criteria of petal width. Like that, this decision tree is shown here. So the conclusion of this project is we have made a decision tree classifier which is capable of predicting the right class in the of the data of this iris data set, and it can also be capable of predicting the right class when the new data is fed to this data set. So that's all about the project. Thank you for listening and coming to this video. Please like, share, and comment about the any feedback or any addition which you want. So thank you.